Good day, students. Welcome to the series where I look at calculus at length. It's primarily grade 12 section, so stick and stay with me throughout this series. And please don't forget to subscribe if you haven't done that. Without regressing in a spectacular way, let me give you the primary guide on how you are going to approach this question in a true sense. The first question is basically your first principle. And by now, you should be counting on this question, the first principle, and at least some parts of derivative in calculus. But however, I want to give you the glowing approach on question 2 and question 1 concurrently. First thing first, we are given the function that is f at x that is equals to minus 5 over x. We want to find f prime at x by means of first principle. So let me write that down, that is 1.1. And we have f at x, that is equals to minus 5 over x. I want you to pay close attention. If they say the first principle, you have to pick up the formula at the back of your question paper, and that is f prime at x, that is equals to the limit as h tend to 0 of what? Of f of x plus h minus the function itself, that is f at x. You divide this situation by h. I think by now you guys know the formula or you're familiarized with the formula. So the best approach to this type of question, primarily when you have polynomials as fractions like that, is to find the difference aside, or you can do it with that h concurrently. It's not a crisis if you trust your capacity. But because some students are not really inclined, I presuppose are not inclined with algebra, I advise that you first work out this one. And that is going to be f of x plus h minus f of x there. That is really going to be equals to, this means in actual fact, whatever in f, in a position of x in f, you are going to place x plus h. So that means it's minus 5 over, now you see x, you're going to put x plus h minus the function itself. So the function is already negative. So you're going to write negative 5 over x, just like that. And then now, what are you going to get? You're going to get a negative 5 divided by x plus h. And in this situation, it results in a positive case. That is 5 over x, like that. Now you're going to apply a basic maths of simplification in fractions. So you take out your LCM there, and that is your x plus h into x. And then now, if you are to be organic on how you simplify that, you're going to get this one, and then it's negative 5. This one cancels with that, so you are left with x, and then a plus 5 into this x cancel with this one. So you are primarily left with x plus h. So let's pay attention there on how we are going to continue with that. So clearly we can see that we get x and then a plus h into x. In the numerator, you are going to be left with a negative 5x and then a plus 5x plus 5h if we are to simplify the numerator quite nicely. So let's see. We are going to get, let me just try to do this. We are going to get x plus h times x. In the numerator, minus 5x and positive 5x, they undo each other. Now we get 5h. So this is the result of the difference of f of x plus h minus f at x. So now we are going to go back to our formula and rewrite it. I'm just going to copy it and paste it just right here. Because now I know the numerator, that difference. So I just need to write, this is the limit as h tend to 0 of that numerator. So I have it here. I'm just going to put it here and then divide it by h. Divide this whole situation by h. So because you have really three quotient lines here, so you need to be very careful Your math should be very strong here. So you're going to say this is the limit as h tend to 0. You are going to say to yourself, this part here in the numerator is divided by h. This is divided by h. Remember, h is over 1. So I'm going to apply a basic math that I've learned in grade 8 rather. This division, we can change that to be a multiplication one. But when we do that, we are going to also write the inv10 of that. That becomes 1 over h. I guess this principle is clear to the majority of you. So I'm now going to erase this one and put the multiplication. And then once I do that, I need to write 1 over h, like that. So you will observe mathematically that you get the limit as h tend to 0 of what? This h and this h are going to undo each other. So you are left primarily with 5 over. That is your x plus h into x. You have to really close that. Now, pay attention. Now that you have really simplified this one, you just need to substitute your h as 0 there. And this becomes 5 divided by your x plus h. But your h tend to 0. So you're going to close that and multiply this by x. And that is really going to be equals to 5 divided by your x into x. Because x plus 0 here is just x. And as a result, you're going to get 5 over x squared. This is how you're going to apply your first principle. And notice that in this particular answer of mine here, the moment I substitute the h as 0, I drop off the limit. Make sure that you don't carry your limit when you substitute that approach of 0 there in h. So this is how you're going to approach the first question. It's 5 marks, by the way. Now you are going to look at the next question, 1.2. They are saying determine dy by dx. You are given the polynomial. There we go. That is y equals to x squared plus 3 into square root of x. Very easy. Let's see how we are going to approach this particular one. So I'm going to write 1.2. We also have 1.2.1, you know, and that is y equals 2 into x squared plus 3 times the square root of x. We can always verify that it's given by x squared plus 3 into square root of x. So because square roots in derivatives are not necessarily allowed, because we are going to use the power rule. That is primarily the rules of derivatives. So we are going to then say this y is equals to x squared plus 3. I'm going to remove this square root and say this is x to the power half. I hope this you know as well. So now we are going to say y equals to, remember, don't derive without writing your polynomial as sums of difference, rather, to put it in that way. So make sure that your polynomials are simplified. By that I mean you say this times that, so the base are the same. You're going to add the exponent. That becomes x to the power 5 over 2. It's more like 2 plus half. So it's 2,5, which is more like 5 over 2 in fractions. And then now you say these two. It's very clear that you're going to get a 3 x to the power 1 over 2. So let's see how far we can go with this one. It seems like from here it's very easy. Now we can take the dy with respect to x. So I'm going to write dy with respect to x, which is going to be equals to, I bring down the power there, and that is 5 over 2. I take away 1 from there, and that leaves me with 1.5, and that is 3 over 2. I mean, that is 3 over 2, yes. So this is 3 over 2. Then plus, you now say half times 3 there. It really gives you 3 over 2. And then you take away 1 there. So that it leaves you with what? With a negative 1 over 2. I hope you know how to really do such stuff. But normally they are very clear to say leave your answers with the positive exponents. So you can say that you can rewrite this in this way to say this is 5 over 2 and then x to the power 3 over 2. This is over 2 here plus you can say this is 3 divided by 2x to the power 1 over 2. Or you can really leave it here if they don't really tell you to leave your answer with a positive exponent. Now I'm going to go to the next question. Let me check the next question. They're saying find f prime at x if f is given by that one. Okay. That is x cubed minus 8 over 2 minus x. So I'm just going to resume that. Okay. So let's see the next one. That is 1.2.2. So we want to find f prime at x if f is given by, it's x cubed and then a minus 8 divided by 2 minus x. This is what we are given. It's always good to verify if what you are copying, it's what it's aligned with what is given them. So now, like I said to you, we have f at x. That is x cubed minus 8 divided by 2 minus x. We have to simplify this particular expression because we in grade 12, you do not use quotient rule and stuff. You know, just like this one, it was the product rule, but you have to simplify it in order for you to get the proper derivative. So I'm going to simplify it. And how do I do that? We need to go back to grade 10 and observe that this situation is called a difference of cubes, where one can factorize that. How do you then factorize it? Let me just put it here basically. How do you then factorize the numerator? You get your x minus 2 into, you square this one, it becomes x squared. You multiply this 2, it becomes negative 2x. Then you negate the sign, it's positive 2x. You now square negative 2, then you get a positive 4. We call it difference of cubes. And then now this one, you can really take out the negative there, and then you get a negative of x minus 2. On the basis that when you multiply this and that, you will get back your denominator. But why are we doing this? It's because we want to simplify our stuff. So this cancel with this one. In essence, we are left with a negative of a x squared plus 2x and then plus 4. And as a result, we get our f at x, which is a negative x squared, the negative 2x, and then a plus 4 there. It's extremely easy, one will imagine. So let me resize this for the benefit of space. So this is your f at x. This is your f at x. We want to find now the derivative of f with respect to x. So this is going to be f prime at x. That is the derivative of negative x squared. It's going to give me negative 2x. The derivative of this one, the derivative of negative 2x is primarily negative 2. The derivative of the constant, that is your 0. I hope you also know this rule as well, that when you derive a constant, you get 0. It's one mistake that students also commit them. So this is how you're going to get the first few marks of calculus. Please make sure that you count on these ones. They normally 14 marks. Here they gave you 15. You know, so far, I mean, they gave you 13. So far you have 13 marks. Now you need to get the other ones. They come quite largely on your cubic stuff. The point of inflation, the turning point, the sketching of the graph, the tangent line. So that's where you should also grab marks there. From there you go to probability. Extremely easy there as well. And your stuff there, calculus. Now, if you look at question 2, You are given the polynomial. Let me just copy this polynomial down. It's f at x is equals to x cubed plus 3x squared and then plus 15. Let me copy it down. It's 2.1, question 2 rather. Let me just write question 2. So they are giving you f at x is equals to x cubed and then plus 3x squared plus 15. Let me confirm that. That is x cubed plus 3x squared plus 15x. Okay. Now they are saying to you, determine the equation of the tangent to h at x is equals to -3, that is h. I need to make sure that I copied h. Okay, I wrote f at x, so I'm used to f. So let me change that to h. So 2.1, we want to find the equation of the tangent. Find the equation of the tangent at x is equals to -3. So when we talk about tangent lines, we are basically talking about straight line. Think about it. This situation has a positive a, like it where you're gonna get your a as positive there. So it means you are going to have this situation if you want to imagine it. So we are looking for the tangent line at x equals to -3. So I may as well imagine it like that. Let me just put it as a tangent. We are looking for this particular line here. Say maybe at that point, x is equals to -3. But this -3 passes through f. Passes through h. I don't know why I'm saying f. I'm used to f. So this is h of x, if you want to imagine it in that way. I'm just trying to make some analysis there. So this -3 passes through f. So at least I need the point of contact. We call this point, let me call this point A. We call the point A the point of contact. So how do I get the y value if I have the x value? I need to plug it into the equation. So let me find h of -3, and that is equal to -3 cubed and then plus 3 into -3 all squared plus 15. This is 15x. And then now I have to put a -3 here. Let's see what do we get there. You can use your calculator. I'm going to use mine as well. It's -3 all cubed and then a plus 3 into -3 to the power 3 and then a plus 15 into -3 there. I'm getting let me check, this will be squared. Okay, I'm getting -45. So here I'm getting a -45. So that means the point of contact at A, that is your -3 for x, and then the y is what is -45. So this is the point where that tangent line passes through. What do you need? You need the gradient. Remember, when we talk about a tangent, we're talking about y equals to mx plus c. This is our equation of the tangent. So you need the gradient. Where do you get the gradient? The gradient at a particular point will be f prime at x. But this x, we know it is -3. So let's derive this one. And then if we derive our h, in this case, it should be h. You'll forgive me, guys, for writing f. So I'm going to put h prime there. We're going to put h prime there. And if you derive h prime, what do you get? You get 3x squared and then a plus 6 there, x plus 15. So you need the gradient. So you will then say, well, the gradient actually at a particular point, let me just write at x is equals to -3. So you get h prime at -3. It's going to give you the value of the gradient, because remember that the gradient is basically the derivative. And then you get 3 into -3 all squared plus 6 into -3 plus 15. This is going to give you the value of the gradient. And then if you are to do that on your K-show, I'm seeing 3, -3 all squared, and then plus 6, -6. Let me really put it here. Plus 6 into -3 plus 15. What do we get? I'm getting, let me check that. It should be -3 here. I'm getting a positive 24. I'm getting a positive 24. I hope you're also getting it that side. So it's a positive 24. So we then now say, well, this is y equals to the gradient, which is 24x, and then plus c. Where do you get this c? We are going to use the point of contact because this is where this line passes through. So this is your point of contact. You are going to use it. There it is. It's -3 and 45. But x is -3, y is -45. Then you will then have to say to yourself, this is -45 is equals to 24 into -3 plus c. Therefore, you get your c as what? Just try to really apply logic then. It's -45. We transpose that, becomes positive. So it's really a positive 27 if I do that. And then therefore, y is equals to 24x and then a plus 27. This is how you're going to find the equation of the tangent at a particular point. And then it's y equals to 24x plus 27. Extremely easy, you know, extremely easy. So this is how you're going to go about this one. We have to look at the next question. It was worth it, eh? The next question, they are saying, show that the function h is increasing for all values of x. It's increasing for all values of x. Okay. H was x cubed. Let me recap my h. That is 2.2. Extremely easy. 2.2, you're given h of x then. That is equals to x cubed plus, this was what, 3x squared and plus 15. That was your h. So we are basically saying this is increasing. Like I said, if you are to sketch it, it's going to behave like that. So where is this graph increasing? It's going to increase when the first derivative, h prime at x, is what is bigger than 0. And it's going to decrease when h prime at x is less than 0. You can also find your turning point somewhere there, you know, and you really see that this thing is going to increase just right from here to here and also from here to here, but in between it's going to decrease. But we don't want to really work you in that way. So we wanted to work through the roots of derivative. So you say, let's get the h prime first. That gives us what? This gives us 3x squared and then a plus. This is going to be 6x. And then I don't know why I keep forgetting x there. And then the derivative of that is now going to be positive 15. So because you can see that 3 gets into each term there, what you can do is you can take it out. So you'll be left with x squared and then plus 2x and then a plus 5, I would like to believe. And then from there, you can complete the square of this one. I want you guys to see something. This is going to be 3 into x squared plus 2x. If you try to complete the square of that, it's going to be half of 2 squared is like 1. You subtract 1 again, and then this becomes positive 5, which is this one. I'm not mushrooming it from anywhere. Now, this is going to be equals to 3 into your x squared. In fact, I can group these ones because they form a perfect square, which is the meaning of completing of the square. I'm going to group these ones. They form a perfect square, the first 3 terms. So that is your x and then plus 1 all squared. It's the same as the first 3 terms. And then these ones, it's primarily what? It's primarily positive 4. and then you close that. And then you can remove your brackets there quite nicely. This becomes 3 into your x plus 1, and then you square that, and then this becomes positive 12 if you multiply everything by 3. So we are saying show that this situation it's increasing. So it's going to increase if you have your h prime at x bigger than 0, which is what we are finding here, and we get that one. So I want to warn you with this situation, because this one is a term that is squared. Whatever value of x there, let me just say x plus 1 all squared, it's always positive. It's always going to be a positive. But I can include a 0 because when x is negative 1, here I'm going to have negative 1 plus 0. I'm talking about the inside part. If x is negative 1, I'm going to get negative 1 plus 0, which is 0 all squared, which is still 0. So this is going to be positive situation. Whatever value of x I can put here, it's going to be positive because of that square there. Now I can then say to myself, this 3x plus 1 all squared again is going to be bigger or equals to 0. On the basis that if x is negative 1 still again, the whole situation is going to be a positive situation, but with 0 it's also included, because if x is negative 1, I'm going to get a 0 there. Now, you will agree with me that this is a positive term plus a positive term. So that is also a positive situation. So I'm going to say, well, 3 into x plus 1 all squared plus 12. This is really going to be bigger or equals to 12. On the basis that if x is negative 1, this is going to be 0 plus 12. So I'm going to get a 12. That's why 12 is included in there. All right. I know it's a bit confusing, but this is how we should work it out. And again, if you were to take anything else above, except negative 1, you're going to get a positive number that is bigger than 12. But if x is 0, you're going to get 12. Hence, this 12 is really included in there. So therefore, your h prime at x is positive. It's bigger than 0 basically. That is bigger or equals to 12. This was your h prime at x. So this implies that your h prime of x is always going to be positive. Bigger than 0 means always positive then. All right. So now you conclude to say, therefore, h is increasing. H is increasing for all values of x. This is how you're going to approach this question. Yeah, it was worth it. A bit tedious at times. You guys saw that. So if there's any question that you think I can clarify on this one, please guys don't be afraid to comment. I'm always here to check your comments. And thank you very much guys for watching.